Hi everyone. Today we're going to be going over Project 2 Warehouse, and we're going to be talking about Part A and to give you a little bit more of a description about it so you understand it a bit more. So to start off, let's look at the project document that you were given. In this document, in the description, it tells you that you're going to be writing a planner to guide a robot through a warehouse to retrieve and deliver packages, and that you're going to be working in a rigid and blocky world, so like a grid system. So let's look at the example that you were given for Part B and work back from there to how that would work out for Part A. First, let's add some grid lines to make it easier to see the grids. So first, the biggest difference between Part A and B is going to be that um, the two numbers are actually switched and are all positive in Part A. So this is going to actually work more like a matrice where you've got the first number is your row and the second number is your column. Whereas in Part B, you can see it's more of a Cartesian system. So the top left cell in this would be 0, 0 in both cases, but then to the right of that, instead of 1, 0, it would be 0, 1. To the right of that, be 0, 2. Below that, it would be 1, 2, and then the bottom right, or maximum extent of the warehouse, would be 2, 2. So let's look at the inputs that you're going to be working with. You are going to have a warehouse list and then a to-do list. In the warehouse list, you're going to have a list of strings that are going to describe the warehouse, where a period is an empty cell that's traversable by the robot. A hash sign is an obstacle that you cannot pass, and the @ symbol is the drop zone where you have to drop packages off at, and where your robot starts. You're also, in Part A, going to have alphanumerics 1, 2, 3, 4, A, B, C, so on, to denote boxes in that warehouse. And this is where you're going to need to look at the to-do list because you're going to have to deliver those packages in order according to that to-do list. Right now we've got coordinate systems for the to-do list, but in Part A you're going to have actually numbers and letters, so let's erase that and call the boxes 1 and 2. So you see we've updated the warehouse list description, and in the warehouse you can see boxes 1 and 2 now, where 1 is sitting nicely in cell 02 in the Part A coordinate system, and box 2 is actually between two squares, and that can happen in Part A. It has to be completely within one or the other, so let's assume it's in square 0, 0. So from here we can go ahead and initialize our robot to see how you would go about picking up the packages and returning them to the drop zone, because your planner is going to have to actually give a list at the end once it's completed of this route to navigate the warehouse and return packages. So first off, you are going to go with move 1, 2 because that's the only move we can really make to get to box 1, and any other moves would be illegal, where you would run into either an obstacle or a warehouse wall. And remember that you can only make straight moves and diagonal movements for any distance. So now that we're adjacent to box 1, we can go ahead and use the lift 1 command to pick it up. Next, since we're already adjacent to the drop zone, we can go ahead and append to our list of commands a drop 2, 2 command to drop it at the warehouse. Now, this wouldn't work if you were right on top of the drop zone, so you've got to make sure that when you're doing this, you check that if you pick up a box and wherever you're dropping it, you're not actually on that coordinate or square. So let's go ahead and move back to the drop zone. You can see that now as soon as the box is dropped, it disappears from the map and you can move right back to it. So next we need to move towards box 2. We've got two choices. We can either move 1 space ahead straight, or 2 spaces. We'll go ahead and move to 2, 0 and move 2 spaces. Because you're going to want to reduce the amount of movements and costs that you take to get an optimal path to succeed in this. So next let's move up to box 2. Go ahead and pick it up. And now we've got two choices of going back 1 or taking the diagonal. In this case we'll go ahead and take the diagonal. Even though it looks like you can't make that diagonal, in part part A, actually, you can, and that's a legal move. So then from here, we can go ahead and drop the box with down 2-2, and then the box will, all the boxes will have been delivered, so you have completed this test case. So hopefully that helps everyone a little bit understand this question, and good luck. Let us know if you have any questions. Thanks.